Hi, this is Subhashmita Majumdar from IIPS DAVV Indore, and here I am to give the solution for the question floating point representation. This was the question in our NAD internal, that is numerical analysis and design. So starting with the question floating point representation. Now what is floating point representation? In computing, floating point is a method of representing an approximation of a real number. In this floating point representation, whenever truncation is done, it leads to error. Some of these errors are discussed. Associative law isn't verified. So according to associative law, a plus b under a bracket minus c is equals to a minus c in a bracket plus b. So if we take values, some random values of a as 0.5665 e to the power 1, that is into 10 to the power 1, b is equals to 0.556 e to the power minus 1, that is 10 to the power minus 1, and c equals to 0.5644 e to the power 1, that is 10 to the power 1. So we calculate the value of a plus b, and which comes out to be 0.5720 e to the power 1, and then we subtract c from this value. So we have the value as 0.7600 e to the power minus 1. The result that we get here has been normalized here so that this can be represented in a floating point. Now taking the RHS value, that is the right hand side value, we evaluate a minus c, which comes out to be 0.2100 e to the power minus 1. A minus c plus b comes out to be 0.7656 e to the power minus 1. So this is the value that we get after solving the RHS, and this is the value that we get after solving LHS, and clearly it's seen that these values, they do not match, and therefore a plus b minus c is not equals to a minus c plus b. Now further we see that distributive law is also not verified. So let's justify this. So according to distributive law, a into b minus c is equals to ab minus ac. Now again taking the values, some random values of for a, b and c, we solve the LHS part, which is b minus c. We first solve b minus c, which comes out to be 0.1000 e to the power minus 1, and then we multiply the value of a to this value, which comes out to be 0.5550 e to the power minus 1, and then we solve the RHS value, which comes out to be AB, which is equals to 0.2524 e to the power 2, and AC, which comes out to be 0.2519 e to the power 2. And then if we subtract these values, the value comes out to be 0.5000 e to the power minus 1. So again you can see that the LHS part and the RHS part, they do not agree with each other. So hence a into b minus c is not equals to ab minus bc. Now solving a quadratic equation, that is x square plus 2x minus 2, wherein the value of x can be found out using this formula. So with this formula, wherein a is the coefficient for x square, which is equals to 1, b is the coefficient for x, which is equals to 2, and c is equals to minus 2. So putting on these values in this equation, we have as minus 2 plus minus under root of 12 upon 2. So the roots obtained are minus 1 plus minus under root 3. When represented in floating point representation, on the representation, the roots will be 0.7320 e to the power 0 and 0.2732 e to the power 1. When 0.7320 is substituted in place of x, and this was the quadratic equation that was given, and is computed by floating point arithmetic, we get minus 0.1000 e to the power minus 2. So if x square plus 2x minus 2 is computed, then we get minus 2 minus 0.2000 e to the power minus 3. So in this way we get different values for the same root. So so a very basic thing is that we know that x plus x plus x plus x plus x plus x equals to 6x, and if we take a value of x as 0.6667 e to the power 0 and we evaluate this whole term individually, that is adding the values of x each time, we get this as 0.3998 e to the power 1, and if we evaluate just the RHS part, that is equals to 6x, we get 0.4000 e to the power 1. So you see that the LHS part and the RHS part do not agree with each other, they are not in reconciliation, so therefore an error has been spotted again. So you can see that these are the various problems that we get where for floating point representation of number, that is associative law, distributive law aren't satisfied, and these are some of the errors that you again get on wherein the RHS part and the LHS part, they do not match each other. So I hope this video lecture was important and was beneficial to you. Thank you and have a nice day.